Grab any giant pile of numbers from the real world. The populations of every town on Earth, the length of every river, the price of every stock. Now look only at the first digit of each number, just the leading digit, and count how often that digit is a 1. Your instinct says it should be about 11%. After all, there are 9 possible leading digits, 1 through 9, so each should show up roughly equally. But that is not what happens. In collection after collection, the digit 1 shows up first about 30% of the time, nearly a third. Almost 3 times more often than you would expect. And the bigger the digits get, the rarer they become as leaders, all the way down to 9, which starts a number less than 5% of the time. This is called Benford's law. It is real, it is everywhere, and it is so dependable that accountants use it to catch criminals. By the end of this video, you will see exactly why the universe of numbers is so strangely lopsided. Let's look at the pattern itself, because it is beautifully precise. If you tally the leading digits of a huge, naturally occurring dataset, you get this staircase. The digit 1 leads about 30% of the time, 2 leads about 18%, 3 around 12, and it keeps falling. 4, 5, 6, 7, 8, each less common than the last, until 9 brings up the rear at just under 5%. It is not a vague tendency, it is a specific, repeatable curve. And here is the part that should bother you. This same staircase appears in wildly unrelated places. The heights of the world's tallest buildings follow it. So do the areas of countries, the populations of cities, the numbers printed in newspapers, the death rates from diseases, even the digits buried deep in physical constants. Data sets that have nothing to do with each other, measured in completely different units, all settle into the exact same lopsided shape. That cannot be a coincidence. So what could possibly connect rivers, stock prices, and skyscrapers? Before we explain it, we have to rule out the obvious objection, which is that maybe the numbers just aren't random. And that's true, but it makes things stranger, not simpler. Here is the real clue. Benford's law does not care what units you measure in. Take the prices of every stock on an exchange in dollars, and the leading digits follow the staircase. Now convert every one of those prices into euros, or yen, or Bitcoin. The actual numbers all change completely. And yet, when you count the leading digits again, the same staircase appears. The pattern survives. This is called scale invariance, and it is the heart of the mystery. Any law that is going to hold no matter what you multiply the numbers by must be tapping into something deep about how numbers are spaced. A truly random process, like rolling dice, would give you a flat, equal distribution. Every digit 11%. Benford's law is the fingerprint of something else entirely. Not randomness, growth. So here is the key idea, and once it clicks, the whole thing falls into place. Stop thinking about adding and start thinking about multiplying. Most things in the real world don't grow by fixed amounts. They grow by percentages. Money earns interest. Populations grow by a rate. Companies expand year over year. So picture an investment of $1,000 growing at a steady 10% a year. Watch its leading digit. To climb from 1,000 to 2,000, the money has to double, a 100% increase. At 10% a year, that takes more than 7 years. The leading digit is stuck on 1 for all that time. But now look at the other end. To go from 9,000 to 10,000, which flips the leading digit back to 1, is only an 11% increase. That takes barely 1 year. Do you see it? A growing quantity spends a huge stretch of time with 1 as its leading digit, and only a brief flicker on 8 or 9. It lingers at the bottom and races past the top. Add up millions of growing quantities, all doing this, and the digit 1 wins by a landslide. To make that precise, mathematicians use a logarithmic scale. And this is where Benford's law stops being mysterious and becomes almost obvious. On a normal ruler, the numbers 1, 2, 3 are evenly spaced. But on a logarithmic ruler, the spacing reflects multiplication, and the gaps get smaller as you climb. The distance from 1 to 2 is wide. It takes up about 30% of the way to 10. The distance from 2 to 3 is smaller, and from 9 to 10, it is a thin sliver, just under 5%. Now here is the punchline. If your data spreads smoothly across many powers of 10, which real growing data does, then it spreads out evenly along this logarithmic ruler. And the chance of landing in any digit section is simply the width of that section. The width for 1 is about 30%. The width for 9 is under 5. That's it. That is the entire law. Benford's distribution is nothing more than the leading digits inheriting the uneven spacing built into logarithms themselves. Now for the part that puts people in prison. Here is the crucial fact about Benford's law. Real data obeys it, but humans, when they make numbers up, do not. When a person sits down to fake a set of financial figures, they instinctively spread the digits around to look random. They use far too many 5s, 6s, and 7s as leading digits, and nowhere near enough ones. Their fakery is too even, and that unevenness from Benford's curve is a flashing red light. So forensic accountants run real ledgers, tax returns, and corporate books through Benford's law. Genuine numbers fall neatly onto the staircase. Cooked books do not. The technique has been used to expose accounting fraud at major companies and to flag suspicious tax filings, and Benford analysis has even been accepted as evidence in court. The fraudster's mistake is almost poetic. In trying to look natural, they forget that nature itself is lopsided. Their numbers are too fair, and being too fair is exactly what gives them away. So the next time you see a long list of numbers, a spreadsheet, a financial report, a table in the news, remember that there is a hidden order running underneath it. Not something anyone designed. Just a quiet consequence of the fact that the world grows by multiplication, and that multiplication lives on a logarithmic scale where the low digits get all the room. It is strange to think that the populations of cities and the prices of stocks and the lengths of rivers are all secretly marching to the same rhythm, set by the shape of the logarithm. And it is even stranger that this rhythm is so reliable that breaking it can betray a liar. The number 1 leads again and again, not by accident, but because that is simply how numbers are spaced. The world counts in a lopsided way, and now you can see it. This has been actually rendered, where we show you how things actually work. If this rewired how you look at numbers, you know which button to press.